which is physical design. Uh, so picking up from where we left last time, you conducted all those interviews, you collected what needs to be there in the Wildwood database, you made the ER diagram. Now you are done with the virtual design of your database. Now you are ready to physically make your database. So there's the next part. After the virtual design, it's the physical design of database. And to do physical design, we use SQL, Structure Query Language, which is the language of relational database, RDBMS, and we call it relational because the tables are related to each other. So any database you use, majority of the databases out there are relational database, and they all use structure query language. Structure query language has been existing for quite some time now, 30 plus years. Of course, there are certain modifications, functionality being improved, but it's been there for quite some time. And as I mentioned earlier, SQL stand for Structured Query Language. And the great thing about SQL is that it's a technology independent language, which means we are using SQL in this course with Access. If tomorrow at your workplace you use Oracle, SQL Server, or whatever database you use, whatever you learn in this class can be applied to any database you use. And even in my handout, at the end of my handout, I have given you various formats of, like, for example, if you create a table like this in Access, how do you do the same in Oracle and SQL Server? So you can see in the appendix section of my handout that the syntax is quite same. There might be a very minute difference, like semicolon or things like that. So that's a good part about SQL, is that it's a technology dependent language. The other thing about SQL is that SQL is a declarative language, and that's a typo there. It should be fourth generation language. What that means is what that declarative language plus what does fourth generation language means is, right now you have 1GL, first generation language, second generation, third generation, and fourth generation. So languages like C++, Java, these are third generation language. Languages like Fortran, COBOL, BASIC are second generation languages. And I think COBOL is, I'm sorry, first generation language. So the first generation language are closest to the language of machine, or assembly language, which is the language of machines. And the first generation language is closest to the machine language, but the further away from the natural way we speak English. On the other hand, fourth generation language, which is SQL, is furthest away from the machine language, but closest to how we how we communicate naturally. So what that means is that when we are using the fourth generation language, it's very easy to use and understand because it's so close to how we naturally speak English or communicate with each other. Plus, the other part of SQL is, as it says, declarative. Unlike C++, Java, where in a syntax you describe that how a certain task would be achieved. In declarative task, as my slide says, you say what you want to do, but not how. And the reason it's not how, because there are some common words which already has a predefined meaning in SQL. So SQL already has taken care of it. And we will see when we start doing the example that how close it is to our natural way of communication. Okay, and so there are three main kinds of functionalities which we can do with SQL. The first one is to view data from database for basic data summary, summarization, consolidation of data, pulling data from multiple SQL tables and databases. Then the second one is it allow us to add, update, or delete data from our databases, and finally the third part is that we use it for creating relationships among table, which is DDL. Now, what is this DDL? I have it right here. So SQL language can be divided into three categories: DDL, data definition language; DML, data manipulation language; and DCL, data control language. So when you, as a first starting point, when you want to create a database and you start with creating tables and you want to establish a relationship between them, you use something called DDL. That's what we will learn in this course. That's what chapter number 6 is. Once you have your data, your tables created, and now you want to play around, you want to manipulate data in your tables, you want to create reports, you want to say, I want to see students who live in zip code 44805. So you're manipulating your data. For that, you use DML. DML as a business analyst, IT analyst, data analyst is what you will be using most of the time. The reason I'm saying that and that you will not use DDL a lot of time is because a lot of places the databases are already created. So you will not create a new database. And additionally, databases are generally created by database administrator. So even though I will teach you DDL, and it's good to have understanding of DDL as a starting point because you're learning databases, but most of the time these are the SQL commands, statements which you will be using. The third one, DCL, is what is used by database administrators to maintain a database. For example, updates, backup, administrative things. So that's we are not going to get into those. And then I have this picture right here. So yes, there's a question. Okay, looks like there's no question. Okay, so as you can see, DDL, you have the create statements, DML, insert, manipulate, and most importantly, select statements, and DCL is mainly to control the database. So we will be learning DDL and DML in this course. The few of the slides I've you might see they are same starting slides are same in chapter number 7 as well. So let's get started with DDL. Before I open a database, certain conventions. Now these are the conventions which I am suggesting. You will see that every company have their own conventions for writing SQL statements. You can follow whatever conventions you think are appropriate, but whatever convention you follow, be consistent. And of course, in a workplace environment, be consistent with what your company does so that this SQL statement can be shared, understood by other people. In my class, if you start calling, if you give a table, if let's say there's a table called student and you say, I'm going to name it as student underscore TBL so that it's easy to understand this table, then do that for every table. If, for example, you say, I'm going to write the table names as capital, then do that for all the tables. Or if you say I'm going to write only the first letter as capital, then be consistent. So whatever you do, be consistent. The other thing which I very strongly will ask you not to do is, for example, even in a table name or an attribute, let's say first name. So, you're writing a table name as student, and this is one of the attribute, first name, last name. That's a big no-no. No empty spaces at all. So first name would be like that, like that. So please, no empty spaces, either in the field names or in the table name. All the commands, which I'll show you in a minute. For right now, you say, what is a command? But for now, just understand every command. Command simply means that when we use a command in a SQL statement, it has a predefined meaning for the database. So all the commands would be capitalized. So that way we understand that that's a command. So some conventions, ending a table with underscore T or TBL, and as I said, no empty spaces. Same thing if you customer ID, nope, not like that. Either put underscore there or like that. Okay, so follow one of those. Whatever conventions you follow, be consistent. So in this class, in our this next assignment, whatever convention you follow when you're converting your now ER diagram to a database, be consistent in your conventions. Okay. Next, my slide shows you how to open Access. Let's just skip for that. I want to cover a couple of more things. Then we'll straight away jump into Access. So first, I will start is teaching you how to create a table and how to insert data into that. So when you are ready to create a table, there are three main parts of it: column, data type, and constraints. Okay. So this is an example of a table which has some data in it. It's a client table. But before we can start entering data into client table, you wanna design this table. And most likely, at least in our example, you would have already created an entity called client with, and that entity would have attributes: client number, client name, street, city, state, postal code, amount paid, current due, recruiter. And client number is your primary key. That means that's unique for every row of data. Okay. I have mentioned this before also. For a primary key cannot be empty, null, and it always have to be unique. Now, what is this foreign key here? So let me explain to you the concept of foreign key. So I want you to understand that in your ER diagrams, you already did, all of you, I've looked at some of the homeworks you did assign the primary key, but only very few did foreign key. But I told you don't have to. So that's fine. You will not lose points if you did not assign a foreign key. But let's understand we understand primary key. Primary key is that attribute in your entity which is unique for every raw data: client number, student ID, social security number, driver license number, purchase order ID, things like that. But now, what is this foreign key? So this is your ER diagram from your last assignment. And so if you look at your ER diagram from your last assignment, that's your building. That's your building entity. Let me see if I can turn on my pen here. No, I don't have my. Okay. So you have your building entity right here with building key being the primary key. And then you have your apartment entity with apartment key or apartment ID, apartment number, whatever way you want to use it, primary key here. So can somebody tell me in building and apartment, just looking at these two entities, which one is parent or which, or you can just tell me which one is child here in this relationship? Between building and apartment, which entity is the child? Yes. So no, Rakesh, building is the parent, apartment is the child. One way to know that is the many symbol is always on the child side. Okay. So what happens in the child side is that in the child entity, we also add the primary key of the parent. So let me go back to my sketchboard. Delete this. My sketchboard is on my other screen. Let me change my sharing of my screen so that we understand how do I share, change my sharing. Okay, let me open Paint maybe. I have multiple screens on here and sometimes it gets confusing which screen is getting shared. Okay, so let me use Paint here. Okay. So last time we did this parent and child, and if you remember, parent has parent ID, which is the primary key, and child has, every entity has to have a primary key. So this is the primary key for this one. One-to-many relation, every parent has to have a child, minimum none. This one optional, one and one, minimum one, maximum one. So parent is the child of this is the parent and the child. So the child as a rule will have the primary key of the parent, which is called parent ID here. So as a rule, whichever is the child entity, it would contain the primary key of the parent. And it is called foreign key in that. So again, let me repeat this. Every child entity will also have the primary key of its parent, and that ID in the child entity is called foreign key. So in apartment, oh sorry, in lease, lease has many symbol of apartment and tenant. So it has both tenant key here as foreign key and apartment key as foreign key. Same way, rent payment is a child of lease. So it has lease key as foreign key. And that's that primary key and foreign key. That is what relates a database. That's why it's called a relational database, because this primary key and foreign key is what connects two tables together, and that's why it is called relational database. So the definition of foreign key. Okay. So now the third piece of it, referential integrity, which is the third part of why databases are so much better than Excel. We understand the primary key, foreign key, referential integrity. Okay. Same example. Referential integrity does two things for us. Let's say, again, my question to you, I have now, time has come, let's say just for the sake of example, to convert this ER diagram into a physical database. I created apartment table and building table, and building has, sorry, apartment has building key as foreign key. Okay. So let's say I enter some data here, apartment key 101, number of rooms 2, and building key, let's say I call it B01. So I enter B01 right here in foreign key. What your databases do is they go and check in the parent table whether that B05 exists. If B05 does not exist here, it will not let you enter B05 here. This is called referential integrity. This maintains the integrity of data. So you can enter only that data in this foreign key, which also exists in the main parent table in the primary key. So that makes sure that the data is consistent across various tables when they're connected to each other. And we will start seeing that with our first example.